In the previous section that we looked at systems of inequalities. And to be a solution to a system of an inequality, a point had to work for both inequalities. And we did some highlighting. We would draw a line, we would highlight on one side of it, we would draw another line, we would highlight on one side of it, and wherever they intersected, those were our solutions. Those were points that worked for both inequalities. Well, in this section, instead of having inequalities, we're going to have equations, and we're looking for points that satisfy both equations. So for part A, we want to see if this ordered pair 6, 1 is a solution. So to be a solution, it has to work not just for one or the other, but for both. So let's check out the first one, 6, 1. So we're going to take the first equation, and we're going to replace x with 6 and y with 1 and see if that works. Well, 6 plus 1 is 7, so it works for the first equation, but that still doesn't mean it's a solution. It's a solution for that equation, but not necessarily the whole system. So we take the second equation, and we replace x, and we replace y, and see if this works. 5 times 6 is 30. 2 times 1 is 2, and 30 plus 2 is not 29. So that means that is not a solution to this system of inequalities. It's only a solution to one of the equations. It's not on both. So let's check the second one. Let's check 5, 2. So if we take the first equation, replace x with 5, y with 2, 5 plus 2 is 7, so that point works for the first equation. Now let's check the second one. We're going to replace x with 5 and y with 2. 5 times 5 is 25. 2 times 2 is 4, and that does work also. So since that ordered pair works in both equations, then yes, that point is to this system of equations. So that's how we determine if a point is a solution to a system or not. Does it work for all included equations? So this one has us do the same thing, and I'm going to work with point B. I tried to do this to remind us about fractions. So let's try the point 1/2, 5/6, and see if it's a solution. If it fails to work in either equation, then it's not a solution. So I'm going to take the top equation, and in place of x, I'm going to put 1/2, and in place of y, I'm going to put 5/6. Now, since the 3 is not a fraction, I'm going to put it over 1 to make it a fraction, because it's 3 times the y value, 3 times 5/6. Order of operation tells us to multiply before we subtract. If we're multiplying 3 over 1 times 5/6, we can reduce before we multiply. 3 goes into 3 once, 3 goes into 6 twice. So we're left with 1 times 5 on top, 1 times 2 on bottom. We have the same denominators, so we keep the denominators, and we combine the numerators, 1 minus 5. Well, these are opposite signs, so we subtract. We subtract 5 and 1 and get 4. Take the sign of the bigger number. Negative divided by positive is negative. 4 divided by 2 is 2, and that's what's on the other side. So that point works for the first equation. We don't know about the second equation yet, but that works for the first one. So now let's take the second. In place of x, we're going to put 1/2. In the place of y, we're going to put 5/6. Here we can make this 6, that's 6 over 1. 2 goes into 2, 2 goes into 6. So we're going to have 3 times 1 over 1. The other fraction is 5/6, and we want to see if that equals negative 12. Now remember, to combine fractions, we have to subtract or to add fractions, we have to have the same denominator. So our common denominator will be 6. So we're going to multiply top and bottom by 6 to make our denominators match. So 3 is the same as 18 over 6. So 18 over 6. Well, the left side is positive, the right side is negative, so even if the numbers matched, it wouldn't be equal. 13 over 6 is a little bit more than 2, not negative 12. So that ordered pair, it worked in the first one, but it does not work in the second one, so it's not a solution to our system. So that's how we check to see if a particular point is a solution. But what if we're not given a point? What if we're told, find the solution to the system of equations, or solve the system? The first method we come across using is to graph. Graph both equations and find out what point is included for both equations. So if we do y equals x plus 2, we have a y-intercept of 2 and a slope of 1. Or as a fraction, that's 1 over 1. So rise 1, run 1. Rise 1, run 1. So if we draw that line, let's connect those dots, and our line is here. So that's the first equation. The second equation is y equals 2x minus 3. So our y-intercept is negative 3. 1. So we're going to rise 2, run 1. 2, 1. 2, 1. 2, 1. 2, 1. 2, 1. So that line is here. So a solution is a point that works for both equations. Or in other words, it's a point that is a solution to this equation. It's on this line, and it's on this line. So looking at our graph, let's notice this point is on the red line, but it's not on the blue line, so that's not a solution. This point is on the blue line, not the red one, so that's not the solution. This point's on neither, this point's on neither. But if we look specifically right here, that point's on the blue line, which means it's a solution. That point is also on the red line, which means it's a solution of the first equation. Well, if it's a solution to both equations, that's the solution or a solution to our system. That ordered pair is over 5 up 7. So that ordered pair is a solution to our system of equations. And notice that's the only place our points intersect. So that's the only point they have in common, or that's the only solution. All right, let's take a look at this one. Let's graph it. So let's start out graphing y equals 3. Y equals 3 is a horizontal line at 3. Y equals 3 every time we're up 3 points, or 3. So this is the equation. Let's see. Y equals 3. Now let's graph 3x minus y equals 9. 3x minus y equals 9. So let's use the slope and the y-intercept. So if we let x be 0, x is 0, we get minus y equals 9, or y equals negative 9. So x is 0, we're here. That's the y-intercept. Now let's replace y with 0. So 3x minus 0 equals 9. 3x minus 0 is just 3x. And if we divide by 3, we get x is 3. So that's the point 3, 0. That's the x-intercept. Remember, if we put a 0 in for x, we get the y-intercept. If we put a 0 in for y, we get the x-intercept. We draw a line through these points. Notice they intersect. They intersect here, and that's the only place they intersect. And that point is the point 4, 3. 4, 3. So that is our solution. If we plug here, just real quickly, 3 times 4 is 12. 3 is 9. That works. The other equation was y equals 3. Well, at that point is y 3, and it is. So this point satisfies that equation. It has a y of 3. It works in that one. So yes, that point is the solution. It works for both equations. You might notice in this example and in this example that our lines are not parallel. If we have lines that are not parallel, they're going to intersect exactly one time, so we will have one solution. And that's typically what happens. But we may have examples where we have parallel lines and something different could happen, and we'll talk about that in a bit. So let's do this one. Minus 2x equals negative 1. This would be easy to solve for y so that we can use the slope. So to get y by itself, to get rid of this term, we do the opposite, which would be to add 2x to both sides. These are not like terms. One has an x, one doesn't. So we can't combine those. This is in slope-intercept form. Minus 1 is our y-intercept. We have a slope of 2 or 2 over 1. So up 2 over 1. Up 2 over 1. So here's that line. Those are all the points that work for that first equation. Now let's look at the second one. Minus 4x plus 2y equals negative 2. Equals negative 2. So we could do this several ways. We could use the y-intercept and the x-intercept, or we could solve it for y and get the slope. Just to do it differently, let's use the intercepts. So let's get the y-intercept. If we put a 0 in place of x, then we can find out the y-intercept. 4 times 0 is 0. If we divide both sides by 2, we get that when x is 0, y is negative 1, so that's the y-intercept there. To get the x-intercept, we're going to put a 0 in for y. So in place of y, put a 0. 2 times 0 is 0. So we get negative 4x is negative 2. If we divide both sides by negative 4, we get x. Negative over negative is positive. 2 goes into 2, 2 goes into 4, so 1/2. So this is our x-intercept. When y is 0, x is 1/2. Now if you notice, just so that we can see this, I'm going to use a dotted line. So if we draw a line through those 2 points, Notice every point that's on the blue line is also on the purple line. So if a point, this point, that works for the purple, that works for the blue, so that's a solution. This point, that works for the purple, that works for the blue, that works for both, that works for both, that works for both, that works for both. And on a line, there's an infinite number of points. There's an infinite number of points. So any point that satisfies one equation also satisfies the other equation. So there are infinite many points, and as long as it works for one of the equations, it works for both. Sometimes they'll say that the solution is the set of what? Well, they're ordered pairs such that, and then they get us to list one of the equations. So our solutions are all ordered pairs such that our point satisfies that equation. Point works for this equation is also for that one because they're the same equation. If we were to solve the second equation for y, we would also get y equals 2x minus 1. So they're the same equation, even though they look different. To begin with, if we rewrite them, this one and that one are perfect matches. All right, let's do this one. For practice, let's solve it for y so that we can get the slope and the intercept. So if we want to isolate the y term, this is a positive 6x, so to get rid of a term, we do the opposite. So the opposite of a plus would be a minus. 6 minus 6 is 0, so minus y. We want to put the x term and then the constant, the one that doesn't have an x. If minus y is this, y is the opposite. It's positive 6x minus 9. So we just changed all of the signs. So that's what we changed the top equation to. Now let's look at the bottom equation. We want to do a couple things here. When we solved equations that had fractions in them, one thing we wanted to do is clear fractions. Notice in order to get y by itself, we need to get rid of this 1/3. So we could either divide both sides by 1/3, or we could multiply both sides by 3. The opposite of dividing is to multiply, so 3 on bottom, 3 on top. Those cancel, leaving us y. On the other side, we have 3 times 2x, which is 6x. 3 times minus 3, positive times negative is negative. 3 times 3 is 9. So that bottom equation is 6x minus 9. And they are the same equation. So if they are the same equation, every point that works here will work there. So we have an infinite number of solutions. And anything that works for one will work for the other. Now this one asks us what type of lines we have. Do we have lines that are exactly the same, lines that are parallel, or ones that intersect at a single point? So those are our options. If they're not parallel, eventually they're going to touch one time. If they are parallel but different lines, they're never going to touch. There's always going to be a gap between them. So there are no intersections, so we would have no solution. But if they are the same line, if both equations are the same line, then we have an infinite number of solutions because everything that works for one works for the other one. each point is on both lines. So each point would work for both equations. So what about this one? If we solve the top one for y, we would subtract x from this, and we would get y equals negative x plus 4. For the bottom one, if we subtract x from the side, we would get y equals minus x plus 8. We could have noticed at the beginning that they're not identical lines because the equations x plus y is the same for both of them, but 4 and 8 are different. So those two equations are not going to be the same. They have different y-intercepts. If we just randomly sketch them, one has a y-intercept of 4, one has a y-intercept of 8. They have the same slope, which is a negative slope. If they have the same slope, remember lines that have the same slope are parallel. How do I know they have the same slope? Because they're solved for y, so the coefficient of x is their slope. So since those match, their slopes are the same. So they're parallel. If they're parallel, but they don't touch, that means they're not going to touch each other. So in this case, we have no solution. No points are on both lines at the same time. If it's on this one, it's not on that one. If it's on this one, it's not on that one.